Hey everybody, good morning. Happy Monday, hope you're doing alright. Alright, I had to go start another pot of coffee. It is not ready yet. I'm a little bit bummed, so when we break, maybe we'll go get some more coffee. Hey Benny. Alright, thanks for coming along. So we got a couple things today. First, we're going to wrap up Chapter 3, our working with primitive data types. There's not actually too much more to go. A couple other examples that we've got in the textbook of using some cool ways of formatting and stuff. So we'll wrap that one up today, and then we're going to talk about the lab, have a little bit of time to work on the project, and we can kind of go from there. Let's see. So we had Lab 3 was due this morning. We'll take a look at that one. Go edit this one here, and I'll fire up NetBeans, and we'll take a look at the lab. All right. So we're going to do rock, paper, scissors for this one here. If they want to play, and as long as that answer is yes, ask them what they want to throw, tell them if they win, lose, or draw, ask if they want to play again. So this was some quick comparisons. Hey, Lido Star and Official Gap Man. All right. Yeah, definitely morning here. I should have started NetBeans soon. I always forget. It's NetBeans. It's a little slow. So we got our little pseudocode example here. This is like kind of what we could follow through, some of the logic for step by step by step here. And then our job was to translate this one into our Java code. So I'll grab this when we do our lab. And that was for lab 3. There we go. We're almost there. Oh. Awesome. Let me get these closed down. Yep. Yeah. So this is our Intro to Programming course. Visual Gap Man. All right, we'll do Java with Ant, Java application. Call this one Lab 3, and then I want to make sure I put it in my correct GitHub repository. So for you, it would have been your Lab 3 repository. For me, again, I'm just putting everything in the main repository here. That's our Monday, Wednesday repository. All the examples will go out here for you folks. All right, making our new project, and then I'm going to check my GitHub desktop client. If it sees new files, I know I put it in the right location. Sorry to hear it, man. Yeah, definitely, it shouldn't be like reasonably hard. I know some schools have some weird philosophy, and they're like, "Hey, we want to call this a weed out course, and if you don't do well, you're not good for the program." But I hate that kind of model. That's no fun. All right, let's get these closed, and here we go. Lab 3.java. Is it choppy? It doesn't say I'm dropping frames. Is it choppy too, Red? Huh. Let's see. I thought I was doing all right. Yeah, it doesn't show I'm dropping any frames. Bit rate's pretty stable. Let me check over here. Pitch inspector. That's what I thought. Why don't I have that saved? Yes, log in. Yeah, it says it's pretty stable. Not too bad for a bit rate or anything. Generally, I don't take anything late because I'm going over solutions to things read. So like now I can still take it because I haven't actually shown a solution yet. But yeah, if after I've gone over the solution, I can't take it. That's super weird. It says it's pretty stable here. But it's more than just one of you folks saying it's choppy. That's super weird. Let me look and see. Hey, Hector, thank you so much for dropping on by and donating some bits. Those all go to the Student Scholarship Fund over the University of Michigan Dearborn, College of Engineering and Computer Science. Oh, yeah, my computer's unhappy. It's full of maxed out again. I'm going to pull some of these tabs down. Those ETH? Where? The bit icon? Let's see. Okay, now I've got a little bit of free CPU. Is it looking any happier now? My anti-malware service is running. Because, of course, that's what I want my computer to be doing in the morning. Does that feel any better now? A little smoother, I think. Okay, cool. Sorry about that. I think we had our pseudocode here. All right, and so we need to ask them. So if we're going to be using some keyboard input, we need scanner. That's that scanner class. Again, I like to call it keyboard. Book calls it SC. I think SC is a terrible variable name, so that's okay, but it still works. Equals a new scanner, given system.in. It's a capital S system. And then NetBeans will say, I don't know what this is, so we can add our import for us. And then we're off to the races. So we need a place to store their want to play answer. So we can have like a string want to play. It's going to be keyboard.nextLine. But we should probably ask them first, right? Prompt and then get their input. You want to play rock, paper, scissors. Scissors. And then again, I always suggest, tell them what you're expecting here, like a Y or an N or something, so that they know what type of input you're expecting them to enter. They don't necessarily have to give you that, but that's kind of nice. And while they want to play it again, so instead of just a single if, we could say if want to play again. Want to play again equals, and generally want equals ignore case, because that's going to be a little bit easier. It doesn't have to be uppercase or lowercase. It can be anything here. So as long as it equals a Y, we can go and do something. So the only difference here for this to be a while loop, oh, I don't want that extra line, is instead of if, we just say it's a while loop. So if this is true, then the while loop will run from the start of the curly brace to the end of the curly brace. If it's not true, it doesn't run. So it acts a little similar to an if in that it may or may not run. The difference with the while loop is once it gets down to the bottom here, it's going to come back up at the top and say, hey, are you still true? And if it's still true, it's going to run it again, another time. Okay, so we know they want to play, so then we should ask them what they want to throw. What do you want to throw? Or B or something? Rock, paper, scissors. Sure. And then we can have a string for their choice or their throw or anything. That'll be the keyboard.nextLine. Oh my goodness, it's not typing right for me today. And not a full colon, semicolon. Took out my curly braces. All right. So we asked them, and now we get their choice. The computer's always going to be rock, so we need to tell them if they win, lose, or draw. So if they're paper, they beat rock. If they're scissors, they lose to rock. If they are rock, they tie. Then we ask if they want to play again. So we can do some quick checks here. We can say if their choice equals ignore case. We say, how about paper? If they're paper, we tell them you win. Else if they're not paper, well then we can copy paste here. If they are scissors, if they're scissors, they lose. You lose. And then if if we want to be nice, it could just be just an else. Like if it's not paper and it's not scissors, maybe it's rock. But in this case, I think it makes a little bit more sense to check to see if it is rock and tell them you tie, because then we can have just another else here that says that wasn't rock, paper, or scissors. Now this wasn't required or anything, but this is just a nice to have here. So if it's one of the three we're looking for, if it's this, else if it's that, else if it's this. Right? If it's paper, rock, or scissors, we know what to do. If it's not one of those three, then everything else falls into this else bucket and says, oh, I don't know what you were. Right? I have no idea. Then we ask if they want to play again. If you want to play again, we ask Y or N. And then what we want to do here is change this want to play value. Right? Because what's going to happen when we get back to the top of the loop, it's going to say, hey, does want to play equal Y? So we need to make sure that this will change here. And if they enter a Y, great, we'll play it again. Anything other than a Y, probably an N, right? We'll say, oh, okay, it's not a Y, game's over. And then we could, if we wanted, say thanks for playing. Okay, so let's give it a run. Let's see if we can play rock, paper, scissors. So what should we try first? Right, we should try all of our cases, right? We should make sure that it all does what we expect it to do. So we're going to try paper, we're going to try scissors, we're going to try rock, and we're going to try something else. All right, it didn't run. I got to change my settings here. Compile on save is the worst option ever. Not a helpful option. Maybe now it'll run for me. There we go. All right, let's play. Yes, we want to play. All right, let's do rock. We tie. Let's play again. Let's do paper. We win. Yes, let's play again. Scissors. Hey, we lose. Yeah, let's play again. Let's do scissors typoed. Oh, we didn't do it right. No, we want to be all done. That says thanks for playing. Right, so it seems like we're covering all of our options here. Right, we made sure each one of these worked. We made sure, again, this was optional, but it's nice to have. And it all went through. That was our rock, paper, scissors game. Give that a format. Take some of that out. Okay. So I'm going to check my GitHub client, and we'll say in 1500. Rock, paper, scissors is entertaining. So it's a little trickier to do rock, paper, scissors, lizard, Spock, just because there's so many more options. But we could if we wanted to. Just a couple more if-elses. All right. GitHub is frozen. Come on, friends. There we go. 1500. Monday, Wednesday. And it sees all of our lab 3 stuff, so we know I got it in the right place. We'll say lab 3. And then we'll push. Hey, Professor Burp, thanks for coming on by. All right, so we got lab 3 done. Now we're going to pick up and finish off the chapter 3. So I think we had a project for that one, right? We were working in our chapter 3 for Monday, Wednesday. Yes, we did. I'll close out the lab. I appreciate it. Hope you're doing well, my friend. All right, so we went through all sorts of primitive types here that we looked at, right? Dealing with different values, particularly around numeric values. That's the most common. But then we also have characters, and then we also have the Boolean value. Did we do the Boolean? We didn't get to the Boolean. That's okay. We'll get to the Boolean. So the last one then that we didn't get to yet was a Boolean value. So a Boolean is something that is true or false. Right? This must be true or false. Right? And you can say it's capital T, lowercase t true or lowercase f false. That's all it can be. Something is either true or false. Now what's fun about these though is you can use them inside of expressions. You can say, hey, if must be true or false, you picked true or something. True, not true. A lot of people will, if they have a Boolean value, will say, hey, if this thing equals true. And there's nothing wrong here with that, except it's redundant because you're saying, does true equal true? do something, versus just if it's true, do something. So unless you're checking if it's false, right, it already, if it's true, will run this. If it's true, this runs. Right? That's what our if expression does here. So you can give it a Boolean value, not just something that's an expression that gets evaluated like, hey, did their input equal y? That sort of thing. So Booleans are pretty handy for things like that, and you can set them true or false depending on things that happened. You can use them a lot of times for loops. You can keep on going. Lots of fun things. SP Java. So if you submitted, like you had two different versions of it. If it's for the one that's already been turned in, it's not a whole lot we can do. If you go commit the version that you did want, it's going to look like it's late. I think is the problem there. That's why we do that one last sanity check. When you go online, you can view that pull request and look at the code and make sure that's the right version there. I'm really generous with partial points, partial credit for these labs. Again, these are mostly participation points for the labs, so as long as you're getting something in that's close, I'm likely to give you full points for it. Oh no, you're too tired? Yeah, it's a little early still. All right, let's got our notes up here so I know how far we went. So we got through random values. So random is really fun. You can do some cool things there. Where can we go? SP Java, talking about being tired. I feel that. All right, so we looked at some rounding, right? So for our project, we'll need some rounding. Any other questions about project 1? That one's coming up due a week from today now for project 1 or project 1. Right, we're doing our little recipe helper here, so hopefully we've had some practice using some of these from the labs. I've got through the chapters. We need to know how many items we need to buy for each thing, right? And you're going to round things up again here because you can't buy half a pack of anything. Then you're going to use this rubric to give yourself a self-assessment. So the labs don't have rubrics, but all the projects are going to have rubrics, so you can see when I go to score it, if you did it, boom, 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 you get the points. If it's missing something, then you don't get the points for that one. If you got partial points, feel free to tell me, it's kind of there, but not completely done, and I can happy to give you some partial points. Yeah, projects with very similar file names gets tricky, for sure. Okay, so we're asking for their name, and we're going to use their name on all the prompts so that we're kind of familiar and a friendly program. We'll ask them what type of food. So depending on the type of food, we need to do one of these things, right? So if they entered hot dogs, do this. If they entered quiche, do that. If they entered dumplings, do this one. If they entered one that we don't know, right, that else case, like we had rock, we had paper, we had scissors, and then we had everything else, tell them, oh, sorry, I don't know what that is, I can't help you. Like your Echo Dots, your Alexas, and say, I'm sorry, I don't understand that, or I don't know what to do with that. Sure. And we'll ask them for the number of guests, and then we'll calculate the number of items required rounded up based on the number of guests. All right, so that's what we got for project 1. Hopefully you got a chance to get that one started. I'm going to do next week before the start of class. Angeline, yeah, if it's not due yet, you're welcome to fix it as many times as you want. Yep. And then we got lab 4 coming up on Wednesday here. A little more practice with our primitive types. So we're going to do our number guessing game. So we have a little bit of pseudocode here for picking random numbers. Right? Ask if they want to play again. Ask them how high of a number they want to guess to. Generate their random number. And then count the number of times they're going to guess. We need another variable that tracks every time they count, every time they guess. We're going to increase it by 1. Ask them to guess. And then the loop here, so it's a loop inside of a loop, is saying as long as their guess is not correct, let's tell them too high or too low, right? And then keep track of the number of guesses and have them guess again. So eventually, they should be able to guess it correctly. This first loop will stop. we'll tell them how many guesses it took, and then we'll ask if they want to play again, and then the top loop can, oh, do they want to play again, yes or no? Oh, okay, how high do you want to guess? And so on and so on and so on. Right, so that's what we had up here. This was our number guessing game. Okay, so we got that lab to work on. All right. What am I doing? Closing these ones down. There we go. Okay, so a couple other things then we wanted to look at. Some different ways of converting values. I think we skipped over this one just a little bit. So we mentioned smaller numbers will always fit into bigger numbers. So if I have an int for some value as 27, and I have a double for another value, I can say, hey, I'm going to give it the value of my sum value, because a smaller value will fit into a larger value. We can take a look at it after SB Java. Don't worry too much. Yeah, for sure. We can talk about it after. So smaller values fit into bigger values. Right, imagine this is like the, you have a bunch of different sized pipes maybe. Right? The small pipes will fit into the larger slot, but you can't take a larger value and store it in a smaller value. So if I were to say even like a float, some float, I can't give it the another value, because a double is bigger than larger value into a smaller value. So that one doesn't work, but you can do it with casting. So you can say, hey, specifically, I know this will fit. So Java, do this. Let it fit here. So I can say, hey, I want a float for some float can equal, and we say, I want a float value of another value. Another value. So we're saying, hey, take this thing that's a double, but please treat it as a float. Make it fit here. Take a double, treat it as a float. So this is the explicit casting. You say, hey, really turn it into this type here. Hey, thanks so much for following along. Glad to have you here. So that'll do the explicit casting. So when you do it this way, this is implicit casting. Right? It would actually work the same way if we said, hey, please treat this thing as a double, but we don't have to for something smaller to larger. If you want to fit something larger into a smaller variable type, then you have to do the casting, and because you're telling Java, yeah, I know I might lose some decimal places. I might lose some values here. I'm going to be okay with that, is what we're telling it here. Okay, so that's for the casting there. Right, and then we looked at our operators, right? The combined assignment operators, the increment, pre and post increment operators, good. Looked at some methods out of the math class, math seal, math floor, those are good. And random, awesome. Can you view these notes again? Yeah, so it all gets pushed out to GitHub. So if you go back to Desire to Learn, get this one real quick. So in D2L, if you go to the content section, all the code goes to the course repository here. That'll link out. So github.com/ericjaneski/CIS 1500 winter 2022 Monday, Wednesday. So you can view all the code in here. This is my public GitHub repository for you folks. And then I'm also exporting out all these streams here. They're all out exported on YouTube, so you guys can see them after. Yep. Sorry, I should have made that more clear. So that's when anytime I go and commit stuff, it goes out to the public repo. Yep. Awesome. All right, can we take a quick 5-minute break real fast, and then we'll come back and wrap this up. I gotta go take care of something real fast. I'll be right back. Throw some music on for you. It'll be 5 minutes. come back at 10:37. Just take a quick 5 minutes, and we'll be right back. Okay? Yes, definitely a coffee break. Hey folks, welcome on back. All right, thanks for that. All right, so we got a little bit more to talk about here from chapter 3. We're not going to spend a lot of time on all of the different things they show. Definitely you can go out and read it, take a look at some of the examples, but I don't think we need to try every single one of them. They spend a lot of time on formatting, which is really cool. So I want to show you some formatting. They spend a lot of time on this big decimal class, which is fun, and how to use it. So we'll take a peek at them. It's not that we're going to need to do a whole lot of. I think the currency formatter is probably the most interesting one because it does some cool stuff formatting for us. So we'll take a look at that one real quick. So if we have values, right, so let's say please enter the price of an item to buy, and then we'll get that input here. So probably as a double, right? So if I want to go to the gas station and buy myself a Snickers, it's going to be like $1.59 for a Snickers. So we'll do that as a double because probably decimal places make sense. So then we'll have the price is going to be keyboard.nextLine. But remember, we can't take a string and turn it into a double. It says incompatible types. String cannot be converted to double. So we have to parse it. We have to tell Java, hey, do this double.parseDouble thing here. Well, you turn it into a double. So take a string, convert it to a double for me. Now you might be thinking, why can't I just say do this double casting thing like we did here? Well, this only works for numeric types to numeric types. When you have a string type, there is no casting it as, because it's not saying, hey, I know I'm going to lose a little bit of precision here. It's, hey, you literally have text, and we need to convert it somehow. So casting is only for numeric types here, or numeric to numeric types. Okay, so we got the price, and then what I want to do is I want to figure out the tax. So remember, the tax then is going to be 6% here in Michigan. So we're going to say the price times 0.06. That'll give me the tax here. And then I want to print out your total cost, including tax, maybe. So your total cost, including tax, is, and then if I were to do this myself, here's like put a $sign in here, right? And then I can say plus tax plus my price. And remember, you need to do order of operations here. You got to force those two together. Otherwise, it's going to say, hey, you want a string plus a double? You must want string concatenation. Hey, string plus another double? Sure, we'll concatenate it in here. So make sure you do the arithmetic first, order of operations. But this is not going to be very pretty. Right? When I go and run this, it's not going to be the nicest looking thing here. Price of an item to buy, so $1.69 for my Snickers bar is $1.79, what? Like if that came up on the register and it's 10 in the morning, you're like, I don't even know what's going on here. It's not going to work so well. So what we can do then is we can use some built-in formatting. Now, there are some ways to do this yourself. I think the currency formatter is probably the easiest way around it here. So to do that, we need to get this thing that's called a number format, which is really fun. So we're going to say, hey, I want a number format. We're going to call the currency format. Currency format equals, and then it's number format. Oh my goodness, number format. Fingers don't want to type today. Get currency instance. And then I can use my currency format to format things. So in this output here then, I'll copy this one. I'm just going to bump this down a line here. We can say currency format dot format given the tax plus price. And then I can even take out my $sign. So with this currency format, it's kind of like scanner, but there's no new keyword happening here. Don't worry too much about it. I can then use that name dot format to format things. So let's do it again here. Let's get the ugly version and the nice, pretty, clean version here. So $1.69. We get really long, ugly thing, and then we get it automatically rounds and adds a $sign for us. This thing is amazing. The other cool thing, I think it does this. It's been a little while actually since I checked. So if we were to buy, say, really expensive something or other, it even adds in the number digit separators for us. Right? It's going to add commas between thousands and hundreds. It's going to add it between millions and thousands, and so on and so on and so on and so on. Really cool. So it solves a lot of that work for us. Right? We don't have to even do our own rounding because it'll round for us. So a lot of handiness with the formatting here. So there's one for percents, which is fun. You can round numbers and tell it specifically how many digits you want with the number instance. So if you want to round to a specific number of decimal places here, we can do that. So you use a number format. We'll call this one number format, capital F there. This will be our rounding format. I don't know, equals my number format dot get number instance. Then to set the decimal places, you say my rounding format dot set maximum fractional digits. My goodness, how many digits do I want? And then if I want, say, 5 maximum digits here, I'm good to go. Right? We'll set my maximum number here. And then we'll take, I don't know, if we were to do some calculation, how about we just round this out? So we'll say pi to 5 digits is, and then we can use my rounding format dot format, and we'll give it math.pi. Remember, math.pi is a constant in the math library, has its own value, but we don't need all those digits. So if we just round to 5 digits here, we should see 3.14159. 5? Oh, does it round up? It might be, maybe it rounds up. Yeah, 3.14159. Yeah, 92, right? Trying to remember all the digits of pi, that's a little silly here. At one point, I had a lot of them memorized, and I don't know why. It was just something I used to do. So a lot of things I don't have the brain capacity for anymore. Like this stuff. You don't need to memorize any of it. Just know it's out there, and then you can go look it up. Right? Just you start building this little toolkit of, okay, here's something I can do, here's something I can do, here's something I can do. The whole goal is when you come to solve your problem and you think, oh man, it'd be really cool if I could like round numbers, and you're like, oh wait, I know we did that before. And then you go, okay, how do I round numbers? And you find the number format. Right? You don't need to memorize any of it. Don't keep that all in your head. It's not worth it here. Okay. So we can do all the roundings, which is really nice. The percentages are fun too, because people are weird with percentages. And then the last fun one we can look at is the big decimal class in Java. So we can use big decimals. So remember, we only get so many decimal places, and the math is even really kind of funky when we deal with them. And do we look at how the math gets weird if we add up? I think we did when we added decimal places. When we added some of these together. Yeah. I don't know if we did that or not. All right, so let's take two doubles. So a double, first double, like 3.333333, and a double, second double, equals 4.444444, and then we'll get a double result. First double plus second double, and it'll output the result. Right, it should be pretty 7.777777, nice and clean, right? If everything works out. Okay, that one worked out nice. How about we try? Let's go back here. Times. Yeah, I didn't want it to work out so nice. Sometimes it doesn't. Let's add another one here. Result minus 0.001 or something in here you can get it to mess up. And I'm trying to remember. Why is it not working right now? Yep, okay. It's behaving quite nicely here, of course. Times 1.1. This is going to make it mess up. Somewhere in here we can get it. I feel like that one's wrong, but a lot of times you'll end up with like all these trailing decimal places here. So Java's not very accurate with doubles. Let's do this. So how about let's forget that. We'll have a double for result. Starts at 1.1, and we'll say an int number of times to add equals 1, and while my number of times to add is less than, let's do 100 or so, right? We'll say result plus equals 1.01. So it should add 101. And if we add 100 times 1.01, should add 101. And then we'll take my number of times to add, plus plus. We'll add up the result. I think this might do it for us. Let's see. Sometimes Java gets confused. Yeah, there we go. So we added 101.9. Sure, that's probably right here, but all of a sudden we get this trailing 0.0000000015. What's up with that? So the way Java does arithmetic is prone to these errors in the billionths, right? It's hundredths, those are thousandths, those are millionths, those are billionths, so trillionths, in the trillionths here, prone to error. So you got to be careful. So big decimal kind of solves a little bit of this for us here. So this whole thing was to show very precise with doubles in arithmetic. Arithmetic. That's probably spelled right. Okay, so if we want to do big decimals, we can do that here. So I can use this thing called a big decimal, and we'll call this my new total equals a new big decimal. Big decimal, and we'll tell it, hey, I want 100.01. Sure, why not? 101. And then it says, oh, I don't know what this is here, so we need to go add our import. Java.math.bigdecimal is where it's adding it here. Java math big decimal. Oh, we also used our formatter too, our number format. Looks like it added that for us. Java.text, number format. Okay. So I can take my total now, and total dot, I can add other things to it. I can add another big decimal. I could divide by a big decimal. I could find the largest or the smallest. I could multiply by big decimals. I take big decimals to powers. I can subtract big decimals. So we got some fun options here of what we want to do here. Hey, how you doing? Is that Fran T charge? Franti charge? So if I had two different big decimals here, or if I wanted to add to it then, right? So maybe we'll do the same kind of loop over again. We'll reset to 1. We'll take, now the problem is adding is a little slower here. So I need a big decimal to add, equals a new big decimal. And we're going to add, what do we say, 1.01. So then we're going to take our total, and we're going to call add. We want to add the decimal to add. And then when we're done, I'm not familiar with it. We want to take our big decimal, our total, dot, and then we've got a couple options for how we want this to be displayed. Essentially, to string is probably the easiest one for us here. Will just give us the string representation of it. There's also a plain string that's without the exponent field. Maybe that's easier. Got lots of options. And an engineering string, use our engineering notation if needed. Sure, why not? Got some fun options. So let's try a plain string and see how well this does it for us. So if we're going to start at, the other one started at 1.1. So we're going to start at 1.1, and we want to add 1.01 100 times. So we should get to 102.1, right? Because this 100 times, we shift the decimal over, should be 101 plus 1.1. Let's see how well it works for us. Oh, 1.1. Oh, my mistake. So when we add these things together, we definitely added here, but it didn't actually change total. So if you think back to how math works, right? Let me pull this up here. This is kind of fun. And this is why it works a little funny here. Come on, Word. There we go. Blank document. So if you say 2 plus 3, right? That's a 2 there. 2 doesn't change and 3 doesn't change, but you get a new result here. You get a new 5. So same thing works here. All of that to show you. We have to say total equals total plus the 2 add. So we're going to say, okay, do the arithmetic and then save the result here back at total. So it wasn't automatically, oh my goodness, what did I do here? There we go. Total equals total plus to add. Total.add to add. So we're going to change total here. Now we should get back our result the right way. There we go. 101.09? Is that what we were expecting? Oh, you know what? I didn't add it the last time. So, oh my goodness, I keep closing the wrong tab here. So this is less than 100 here. There we go. Less than or equal to 100. That'll let you do it 100 times, because when it got to the 100th time, it didn't actually run it. Let's try it one more time. But you notice we didn't have those trailing decimal places, so I think life is pretty good here. We get an accurate result without all that ugly trailing nonsense there. Feel pretty good about our result here. Okay, so you can use those if you want to get a little bit more precise, a little more accurate mathematics happening. All right, now I've got a proposal for you folks. And my proposal is that we have a lab due in 2 days, and we have the project to do in a week. And I would propose that we don't do another lab today, because then we'd have a lab and a project to do the same day on February 7th. So I'm okay with skipping it if you folks are. It's not, it's some good practice stuff, but not anything that was, I think, super critical here. How do you feel about that? We'll be okay there? So we got time. We'll work on lab 4. We'll work on project 1. All right, awesome. Oh, we got a math exam already? Holy cow, it's only been like not even a month of classes. What is this? This is the start of week 4, right? Oh no! Ooh, okay. Very fun. Yeah, linear algebra is really cool. Depending on what part of computer science you get into, if that's what you're interested in, you'll do lots of fun stuff with linear algebra. It's pretty handy. Pretty handy. All right, so I think that's good then. We've got the rest of the chapter to work on, so we will have a quiz, though I need to go turn on that quiz. Thank you for reminding me. I'll turn on the quiz for chapter 3 here. Make sure the due dates are correct. When I import stuff from last semester, the dates get all funny because, it's kind of what it is. So we got the chapter 3 quiz. Oh, restrictions. That's what I'm looking at. Restrictions here. We need to go change our due date. Let's go today, and then we'll go out a week. So 11:59 p.m. on February 7th. We got all week plus a little bit, so I'll give you one more reminder to make sure that one gets in here for the quizzes. Make sure that one's turned on, and then the answers will turn on after the due date as well. I just need to go change that one here. And I apologize if any marks any of you wrong in the short answers. Just let me know. I'm happy to go correct those. I know it's not the best here for all the different options that are available. So everything in the quizzes comes out of the textbook. So they're literally the question test bank from the author. So anytime you see a question, go find that material, find that content in the chapter, and take a look at and give that a review. Because all the answers should be in there right in the text. So you'll just need to find where that topic is that you're being asked about. And you should be able to go find it. So you should be able to see the answers after the due date. So like once you turn it in, all you'll see is a score. So not until 11:59 p.m. Will you be able to see the answers. It's just my quick little way to make sure that folks don't work together on these sort of things, where like one person turns it in and then they go and look at the answers and tell everyone else what the answers were. So the answers don't turn on until after the due date. So I apologize for that, but I've had issues with quizzes in the past being more of a group work, which is definitely not ideal. So yeah, you'll be able to see it after the due. So you should be able to see chapter 1 now, questions and answers, but you won't be able to see chapter 2 until later tonight. Should be like that. So, and hopefully that works out okay. It puts a little bit of delay in things, but overall I think is generally works out not too bad. Okay. All right, so we've got the rest of chapter 3. You got the quiz to work on, you've got the lab to work on, you got the project to work on. We got about a little less than another hour worth of class or so. So I'll hang around either on Discord or I can pop into Zoom meetings if you folks want to chat, and we can go from there. Any other questions, thoughts, concerns before we end? SP Java, you wanted to chat after, right? So I think you've got, we can use that same Zoom link. It's the same one every time. It's just my standing meeting room. It works out nice. Yep. Thanks so much. All right. If you folks run anything else, let me know. I'll post this recording out here and make sure I commit this stuff to GitHub. There we go. So more chapter 3. Commit and push. So it'll be available to you. And we'll go from there. All right, folks. I'll see you around. Please drop me a line if there's anything I can do for you.